Bismillahirrahmanirrahim. Assalamu alaikum dear students. How are you? It's all about physics. Like and subscribe the channel. Today's our topic law of conservation of momentum. The meaning of conservation is constant mean that remains same. And first of all I define the term momentum. The quantity of motion possesses due to its mass and velocity. P is equal to mv. Momentum is a vector quantity. Okay, for derivation of conservation of momentum, we consider an isolated system. Isolated system mean a group of interacting bodies on which no external forces acted. Mean that before collision and after collision, momentum remains constant. If no unbalanced or net force act on a system, its momentum remain constant. Thus, the momentum of an isolated system is always conserved. The term law of conservation of momentum stated as the momentum of an isolated system of two or more than two interacting bodies remain constant. Explanation. Consider an isolated system of two bodies, masses m1 and m2. They are moving in a straight line with initial velocity u1 and u2. u1 is greater than u2. Initial momentum of a mass m1 is m1 u1. Initial momentum of mass m2 equal to m2 u2. Total momentum of a system before collision is m1 u1 plus m2 u2. Its body m1 moving with velocity u1 and its body m2 that moving with the velocity u2 before the collision. Okay, after some time m1 hits m2 with the same force. According to Newton's third law of motion, m2 exert an equal and opposite force on m1. Let velocities become v1 and v2 after the collision. Final momentum of mass 1 is m1 v1 and final momentum of mass m2 is equal to m2 v2, and total final momentum of the system after collision is m1 v1 plus m2 v2. Okay, according to law of conservation of momentum, the total initial momentum of a system before collision is equal to the total final momentum of the system after collision. So we get this equation m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. It's proved that the law of conservation of momentum remain constant because before collision and after collision momentum remains same. Here I discuss a question that describes the system of a gun and bullet according to the law of conservation of momentum. It is also an application of conservation of momentum. Okay, consider a system of gun and bullet before firing. Both gun and bullet are at rest. So total momentum of the system is 0. Momentum before firing is equal to 0. As gun is fired, bullet shoot out of the gun and acquires momentum. The conserved momentum of the system, the gun recoils. Let m be the mass of bullet and its velocity is small v, and capital M be the mass of gun and velocity capital V with which it recoils. Thus total momentum of gun and bullet after the gun is fired will be m v plus small m small v, its momentum after gun fire. Okay, and according to law of conservation of momentum, momentum before gun is fired and momentum after gun is fired is equal. So mv plus small m small v equal to 0. Momentum after fire equal to momentum before fire. Okay, for finding the velocity of gun, that's it. We get answer v is equal to m minus mv divided by m. This equation gives the velocity of gun. Negative signs of the indicates velocity of gun is opposite to the velocity of bullet. because gun recoils in backward direction and bullet fired in the forward direction. Thanks for listening. Allah Hafiz.